Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, I have no idea how to call it. Let's you do it.
Well, let's start with calling it database version control. So source control,
Schema change management, database schema version control. I don't know.
Yeah.
If you say just database version control, someone can think that it's also about data changes and like time travel for data, and it's very different. We mostly talk about schema, but talking about schema, we should not forget about big data volumes when you need to adjust your data if you need to make some schema change which requires data changes, right? For example, data type change of a column.
Absolutely.
So, yeah.
Well, I guess I think probably in the application world, this is a well-covered topic. There's been various generations of tools that have improved.
I've recently read articles about it. There are 3 generations of code version control or code change management or source code management. First was very naive and log-based. Second was CVS Subversion and others Perforce. It was better, but it was very centralized. It was better in terms
I remember. Subversion, Team Foundation Server. Yeah, some old ones.
Right.
And then more recently.
Third generation is Git and Mercurial, which are also decentralized.
Yeah, and I think...
And like log-free, decentralized.
I don't know anybody using Mercurial anymore, so it seems like Git won, at least.
Several years ago, I know for sure Facebook used it, but I'm not sure about now, yes.
So on the application side, it feels like this is pretty standard. It's very rare that I meet anybody not source controlling their application code, but I do still meet people who don't have the same systems for their database. And it's super interesting because this is a problem I was working on back in even as early as 2010. I was working at a company called Redgate that were bringing out a source control product for a database for SQL Server. So it's super interesting that still, 12 years later, it's still pretty common for me to come across teams that don't have it. And even the ones that do...
Yeah, for database, you mean, right?
For data, yeah, exactly. Yes. Mm-hmm. And even the ones that don't normally have it hooked up to... they're using it for kind of communicating changes between developers, but not always for... deployments or continuous integration or anything like that.
Let's discuss the goals. Let's start with regular code. Which goals such tool like Git is aiming to solve? For example, if you're just a solo developer, it still makes sense for you to track changes and to have history, right? Like, so you can time travel basically in terms of source code. But do you need branches? And do you need multiple versions of your software?
Well, this is super... Do you mean for databases or do you mean for applications?
For regular applications. Simple, like single page application, I don't know, something simple.
If you're on your own, I think... Yeah, if you're on your own, I think branches have minimal additional benefit. I know some people love them for kind of exploring different paths. If they want to try something experimental and then quickly come back and fix a bug for a customer, it's like nice to not have been developing on the main branch. So I can see benefits to that. And also I think it teaches good discipline when you do have collaborators, but I don't see massive benefits. How about you?
Well, this is interesting. So branches can be used in various ways, and if I'm alone, if I'm a solo developer, I still have some benefit of them, because I can, exactly like you said, I can experiment with some path of development and then abandon it if I consider it wrong. And with branches, it's good that they are very quickly. To create them, it costs nothing, very quickly. Boom, and I have a branch I can experiment. and I can have multiple paths of development, and then I choose which one to take. Maybe I will combine multiple ones. This gives flexibility and freedom, right? But also branches sometimes are used not as for free, it's like for feature development or bug fixes. They are used to track different versions of software. And Postgres itself Postgres project doesn't use feature branches, right? It uses major version branches. Like stable release number 15, we have a branch, and all bug fixes are happening inside this branch. So you have multiple lines of your tree of development, and I can easily imagine if I'm solo developer, I develop some popular software, I still can benefit from branches. Like in this particular case, I maintain some old version, I already refactored it a lot, I already have new version, but I still maintain the old one, I need to bug fix it sometimes. So branches are needed for this as well. But maybe we went too far from databases already, right? Maybe not.
Well, I
maybe
think this
yes.
is all I think this is all useful, but I would say that this is where the next major benefit that I was going to mention is obviously in teams, being able to work in isolation and not have to worry about stepping on each other's toes. And that's where it gets super relevant for databases. So when I was at Redgate, we actually supported two different models of source controlling your database. One we called the shared model, because most teams at the time, and probably still now, tended to have, even if they had databases locally for developers, they would tend to have one big database. So I know this is where your product comes in key, but they would have one large database where you could do proper testing, proper checking on decent data volumes, and they had to be really careful of stepping on each other's toes. For example, if you and somebody else happen to be working on the same stored procedure or function at the same time, you get the case where the last one to change it wins, and that's a real problem in terms of testing. If you don't understand why your feature's not working, and then you realize somebody else changed it. So we did support that model, and we actually ended up implementing it via locks, or triggers actually. We called it locks, but you could lock an object so that other people couldn't change it, for example. So there was like some super interesting features around that, but that was a stopgap. I saw it as a stopgap because the better version was we called it the dedicated model. So where everybody had their own dedicated version of the database, and they could make changes in isolation and then commit those back to the repository with all the source code, and maybe push those to a central system, like deploy those maybe to an environment.
But but back to Git as being third generation of source code management systems. There's also some small things which deliver some value. For example, you can easily check diff before you push. So you already committed. You can review your own changes, and with additional additions in form of GitHub or GitLab, you can also have very powerful process of communicating with like a review process for pull requests, merge requests, and so there are multiple levels of quality control, I would say, right? And this is great, and this is like also forking. So if you have open source project, it's easy to just fully clone it, fork it, and develop. And if you see some value, push back changes, propose, suggest in form of pull request or merge request, suggest these changes to the upstream project. But like it's like there are many, and these benefits are not like in the same area. They are like different in the different areas, but all of them allow to build very powerful and very good workflow. And there are many workflows actually, not one, which are proven to be successful in various teams. But back to databases, we know that currently I would say we have like also some generation of schema change management tools. Some people name them. I believe it came from Ruby. I'm not sure. Database migration tools,
Yep.
right? Because Ruby on Rails Active Record has part of it called database migrations, and it's not migrating from Oracle or to Postgres. It's about like schema changes basically.
Yeah, migrating
and-
from one version of your schema to another version of your schema.
Right, and
And
all
if-
of them.
Yep. I was going to say, this is really important. This comes back to your diff point from earlier. In code, in applications, we can diff, and it's simple text files, and we can deploy by overwriting one with the other. And that's fine
Right.
because there's no data, there's no, yeah. Whereas in databases, we need, like, we can't just replace, if we rename a column, for example, we can't just delete that column and add a new one with the new name. We need to be
You
aware
will lose
that that's
data.
a-
Yes.
yeah, of course. So that's a very simple example, but there are loads of these examples, and I think this is where at Redgate we had a huge advantage because we had a schema comparison tool that did these diffs. That was the starting point.
Is this
But-
schema comparison does it happen without context? Like what happens with this example?
This is where it gets really complicated, and I think it's mostly unviable in Postgres at the moment. I don't think anybody's doing this in Postgres at the moment. You need to have a live database, source code files. So these files are create statements, a create statement per object, and you need to be able to do comparisons. But of course, if you're comparing two static files, how do you know if it's a rename or dropping one column and creating another one?
Yeah.
Through static files, you can't tell. So
You need database.
you need to add migrations, or what Rails calls migrations, at some level. So they ended up kind of backing into that and ended up also acquiring a tool called Flyway DB because that was very migration based. So I
Before-
think
Yeah.
just quickly, I wanted to say I think there are two completely different models here. One of which is kind of nice in principle, but I don't think works in practice, at least not yet, which is the static create statements. And the other one, which is a single dump of your schema from a point in time, and then migrations between versions thereafter, which is what all of the frameworks like Rails and Django are doing, and the other tools do as well.
Right, and if you have some live database, even if it's not production, you can distinguish drop create versus alter column if you check system catalogs. For example.
Object IDs, yeah, exactly.
Object or in Postgres it's PG attribute has at num, so like numerical or number where column is, and you can say, oh, this is the same column, like we just renamed. So you can distinguish this case, or versus it's a completely new column. Interesting. So you mentioned Flyway. I know Redgate a few years ago purchased this project. There are other projects like Skitch. I like Skitch because it's like very quite powerful. Although it's written in Perl, so it's hard to contribute for me. It's very powerful and it works with many databases as well. Also, there is very popular like so-called enterprise world. Very. I'm not sure if like I remember they have XML. I mean Liquibase, right? Liquibase is very. Django also, like being framework, Django has database migration capabilities similar to Rails, but all of them, correct me if I'm wrong, all of them live on top of Git. They rely on Git for version control, right? Okay, so what's their value then? Why do we need them at all?
Is it to do with deployments? Is it to do with actually applying the changes, picking them up and tying them to code changes as well? For example, if I have database change that needs to go alongside an application change, that's my understanding.
Yeah, for example, if we talk about, well, of course, obviously, framework in Rails and in Django, they support both frameworks are also ORMs, so migration parts of those ORMs also support like like higher language, not SQL, right? So because it's ORM, so we can change schema also using our native language, trying to avoid SQL. But for quite advanced changes, you still need SQL. For example, if you want trigger, probably you need to write some PLPGSQL code and some SQL code and so on. If you need some advanced CTE, you also need, or define some view with advanced CTE, you need some SQL. But generally, they try to also support native language like Ruby or Python. And also, for example, in Rails, I see that people start, I observe it in multiple projects and GitLab as well. They start with not dumping schema. So they support steps and also dumping schemas for additional control. This is our like current baseline, and we shifted. But usually projects start with schema.rb, I think, in Rails.
Yeah,
and then they switch to structure.sql, which is SQL regular dump. And it's easier for Postgres guys to compare it and deal with it. I remember GitLab did it when they decided to stop supporting MySQL. Before they supported both SQL and Postgres, and it was not possible to have structured SQL, which should be like a single database only. But my question is to these like systems. Okay, you provide some like usually like forward and backward. You can define forward and backward steps. Sometimes you can define also testing step. They allow you to deploy. They allow you sometimes like to have some dry deploy, which not doing anything but checking correctness of your changes. But why don't you care about database data? Database is data. It's not tiny, unlike source code. Sometimes we have millions of code, of course, but usually it's relatively small compared to database. But database is usually big. And if you need to change something without not blocking others, you need to have some DML as well, not only DDL. And this DML should be split to batches. Why don't these all tools support it at all?
I think it's difficult, and I think if we talked about those 3 stages of application progress or application source control progress, I think we're in database land. We're kind of in step 1 still. I think the tools are still quite immature for supporting
generation
us.
1. You like we are in generation.
Maybe, yeah. Maybe that's a bit harsh. Maybe we're like just sneaking into number 2 with some of these tools becoming better. But if you're not on Rails or Django, I think it's actually quite difficult to get this stuff up and running. So one issue, for example, even before you worry about online changes with big data, but actually worrying about zero downtime deployments, even before then, what about merging? What about if I make some changes on a branch and add a migration, and you make some changes on a branch and add a migration, but we want to deploy those together? Like how? If
conflict resolution it's called. Conflict resolution.
Yeah. Merging's definitely a loaded topic in this one, but yeah, so exactly, conflict resolution is difficult.
Yeah, so two questions we raise. Zero downtime migrations, for example, actually basic diff capability. If we rely only on Git, it will be very weak. For schema, we need diff, and not as pgadmin and others have. Very, very naive, or Migra or others. So they have very naive diff. Like, for example, they say create index, not mentioning concurrently. So if we have relatively substantially big and substantially loaded database, we will block them, and only tiny projects can afford using such approach. Yeah. So create index should be concurrently. Alter table, changing column data type, also this is harder. This should be in batches. And so diff, you say conflict resolution. I also say deployment in accordance with this zero downtime approach. So we need batch management background, like workers sometimes lasting days. If you need to update, if you need, for example, to change data type in a column or in a table which has a billion of rows, you need to be very patient and wait 1 or 2 days and split it to batches. Batch size should be properly adjusted. So they don't care about it. Why? Hard problems, or I'm mistaken and it's not needed at all?
I think it's a hard problem personally. I think also
3 problems already 3 problems.
Yeah.
Right.
And I've actually I've got a friend working in this area, kind of, somebody I used to work with called Neil Anderson, working on a tool called Postgres Compare. And I've been trying to encourage him because as you say, the diff tools that have been added to most IDEs and the open source ones aren't super intelligent. They're good. I'm sure a lot of people have put time into them, but they're not, I think he's put a lot more time in, and he charges. It's a commercial tool, and he's been able to put a lot more time into it. So it's called Postgres
Does it support
Compare.
zero downtime migrations?
I'm not sure. I mean, it's mostly for
because this
live
is the
schema
key.
it's mostly for like live schema to schema comparisons, and I don't know if they're like
Only
he's got a
schema
lot.
without data, right?
No, he does do data as well. Actually, it's in the same product,
okay.
but for
Okay.
yeah.
But it's kind of
in-
different features, right? So
Yeah, I think data, like I was going to mention data here actually, because I think data can sometimes be an important part of your schema, which again, some of these tools forget and neglect. If you've got a lookup table, for example, of what the famous one
Dictionary.
is country codes, or exactly, anything where you need that data
people
to
put
be in
it
the database.
to migrations. I see it
Yeah.
quite often in Flyway, for example, just insert.
Yeah.
And sometimes some teams consider this as a bad practice and try to avoid, but some teams do it.
I don't know what the alternative is though. If that's the migration.
Good question. Good question. Good question. I don't know either.
So we had to worry about that because we were having create statements in version control. So if you're trying to do the alternative, which is have a create statement per object and manage diffs, you have to choose which tables need to also go in data-wise. So I think it's a hard problem and complicated. I do have what's it called, like empathy with the people making these products and making these services. I do think databases are fundamentally harder to do this for than applications, but I do also think there's a lot we can do to make them better. The create index concurrently is a perfect example of quite a simple change that probably should be in most of them.
Yeah. Also, you know what? I think if, for example, if somebody developed open source tool which supports zero downtime diff, I think it would resolve the problem. It would solve the problem of merging and conflict resolution, because we would see this diff and this is our merging process. We just maybe something for conflict resolution we need something else, but at least we would be able to merge with actually if we merge to, for example, main branch, it's our deployment to production. No? What do you think?
Yeah, I think merging's trickier, but we might be able to lean on Git for some of that. So for example, if we're changing the same function, the alter function is going to look very similar between our two. But if we're altering a table, maybe we can apply one after the other, but I'm not sure when order matters. It's a tricky one. I haven't thought about this for a few years, to be honest.
If we consider functions triggers as a part of schema, and I think we should, this also
100%.
we probably already in previous episodes we already mentioned the problem of including with all these tools, current generation 1.5 right tools. If we include different file and keep function body there for convenience. Like for example, each function it's in own file, easier to find it, navigate, and so on. Do we still want to support long sequences of deployments? For example, we have several installations of our product, and one is already very up to date, and another one is lagging a few months of changes. And the problem is when you include, you need the current version of file. But when you already function changed many times, and you try to replay old migration file, it tries to include the very fresh, very new function body. And it's not what it is expected like a couple of months ago, right? And we have a problem. So you need to somehow fetch. You can use Git history and fetch older version which corresponds to this migration file. But why nobody cares about this? I needed to implement it myself, and like I thought about how to contribute it to Sketch, and it was like quite hard. Actually, I raised the topic about it in mailing list, and I didn't see support. Things like it looked to me like I'm alone with this problem. Like nobody cares, right? Maybe I'm really alone. How people do this from your practice? Is it a problem, or people just don't need to replay long sequences of changes?
I've seen more people kind of like try migrating forwards. I actually see quite a few people not even worrying about backwards, like moving backwards, and it's an interesting.
It's not only about backwards. It's about
Okay,
also
I think
if
I've
you have
misunderstood.
multiple setups, and one of them is lagging quite much.
Oh, this is.
So you
I
need
guess
to
this is the
replay,
branch.
right?
I guess
They,
this is the
they
argument for using branches.
No,
You
that's not
can.
about branches, because forget about branches. We have only master or main branch. The problem is they're lagging. They need to replay, say, 10 database migrations. And they fetched the very fresh version of our code, but this code already has a much newer function file. And when they try to replay some old migration which tries to include this file, it expected very different function or view, for example. So problem with including different files, it's a problem. You always need to snapshot whole function body to migration, which like bloats your code, right? You cannot keep a function in a separate file. This is the problem with all these tools.
What do you mean by keep? Do you mean so we're talking about database functions?
Okay. For example, let's choose different. Like for example, we keep views. In different files, but views. For example, we changed views, so now we have more columns in newer version, and we have different view which also relies on some. Like for example, we had 3 columns, and then we dropped column. And we keep views in different files, and one view expects another view to have some column, but modern version of that view doesn't have this column. If we include files, maybe I'm coming not well, but problem is when you try to include, and you already like Git fetch very current version today, but included file, when you replay old migration, you expect different. You need to go back in history and replay old version of this file. But it sees new file, and there can be a conflict in it. I think I not explain it well, right?
Yeah, I'm struggling. So is this, when we talked about those 2 models, is this not using migration? Are you using a hybrid of having versions of an object and migrations separately, or if we only have
object in a
migrations,
function, for example, right? Right.
Yeah, if we only have migrations from a baseline, I don't think this is a problem.
Problem with starts when you try to use include some file. Like with Sketch, Sketch feeds files to psql, so you can use \i.
Oh, okay. Yeah, okay.
This is a problem. And if you use \i and this is like 2-month-old migration, this file already changed, and you need to rewind it.
Okay.
And
Okay.
this is a problem. Otherwise,
this
you
is
need
why.
every time to put a whole function body to migration and it bloats everything. It's very huge.
I see what
But I
you
mean,
mean now. Yeah.
this if you put every time you say create or replace function or drop function and create it again and put everything and in revert as well, like whole function again, it bloats it so much that I'm starting to ask why. Like, do we have Git still? No, nobody cares about we have Git here. This is why it was created for, right? Why we copy
Yeah,
paste functions, function versions? Where is version control at all,
this
right?
is what I liked about the single create files per object, but it has such big limitations right now that I don't think it's viable. So I think we have to accept the putting the full object back in. Maybe you could argue it's a
But how?
SQL
I
limit.
don't understand. If you keep object in separate file, how you replace sequences of changes? So like, you still have versions, right? Like our first version, then like maybe timestamp, and you take day or something, timestamp. This is new version, new version, new version. If you keep object in separate file, you need to include it. And
So
if you try to replay very old migration with very new state of code, you will have problem.
I think you need to have a database aware diff functionality, and it also probably needs another folder of overrides. So if you have, for example, easy migrations like adding, if we're always adding columns, adding indexes, adding tables, easy stuff, we don't need to have any special cases. We can just, the diffs are easy. If we do something more tricky, let's say from, I know Git doesn't work like this, but let's say from version 15 to version 16, we need a more complex migration. We can put in a folder somewhere. Here's a slightly more, for going between 15 and 16, which includes going from 14 to 18 or any other way past that boundary. We can say, don't use what you plan to use this override instead. But it gets complicated. That's kind of like a hybrid between the two models we've been discussing.
Well, there's a big difference between objects with data and very
Yeah.
lightweight objects. Objects with data is tables. It's called tables. That's it. Only tables have data. If we forget about materialized use, which is derivative from tables, right?
Yeah.
Views, triggers, functions, they are light, they don't have data. So we always can rewrite them. We can throw them away and
Indexes though,
redefine.
like,
Well, yeah, but indexes it's like part of it's like part of tables probably. Right?
okay, cool,
Because
fair enough.
they cannot live without tables. It's like okay,
Yeah.
it's addition to tables, add-on to tables. But functions, triggers, and views, regular views, maybe materialized views as well because they like have only derivative data as well. You always can redefine them, and you can keep them in files. That's why. It's
Well,
easier
that's
to
a
keep them
really
in
interesting
files.
point. I haven't seen a system that separates those two.
I
It
built
would
it
be
a
quite
couple of times.
okay,
Like
cool. So you had
also
one
remember,
system for tables,
yeah,
one
remember
system
with
only
this
for tables. Go
we
on.
have a delay. Sorry, like
Yeah.
conflicting. Remember we discussed approach when functions are kept in separate schemas and you can keep
Yeah.
old version of this is smart and good, and I think it's possible to build without copy paste still, like to rely on Git for version control and have like version 1 schema version functions version 1 functions version 2 and being able to even keep them several versions at the same time, and it's different application nodes can address different versions of functions. This is very smart, and this is exactly when we probably need to keep functions in separate files as well, right? And I should mention that this idea was came to mind of Valentin Gagichishvili long ago from Zalando, and then propagated to Russia, to Avito and others and so on. So it's a great idea. Still relevant, I think. Not sure about triggers because triggers they consist of function, trigger function plus trigger itself. So trigger itself it's a bit easier. It also requires some things. Oh, by the way, big question number 4 or 5 probably. Why do all these guys don't care about it? Like about simple problem of locking attempts. If you try to alter table, add column, you always must have a small lock timeout and not be ready to retry. Otherwise, well, you don't notice the problem if you have not big load, not high load, right? Not heavy load. But if you have noticeable load, like 1000 TPS, sooner or later you will bump into this problem very badly, as many did already. So you need to be graceful. Otherwise, you try to alter somebody locks, and you cannot acquire a lock, and you have huge line, including selects, after you waiting. So you block everyone. They don't care about it. Why?
Well, I guess
Because it's
not
generation
in-
1.5. Generation
Well,
1.5. That's why.
It's a really good point, but that also lives in a slightly different place, right? That lives in the config file, and that's not necessarily. Well, is that in version control? Hopefully, but it's not in the same version control for most people. So it's deployed in a different way, updated in a different way. So it's very, very interesting. Yeah, really good point. Maybe that should be in there as well.
I hope they will develop in the right directions. People need these directions. People need zero downtime migrations, conflict resolution, graceful deployments, right? And by the way, I want to advertise GitLab has open source and background migrations. It's called migrationhelpers.rb file. So it's open source, anyone can check, and if you are Ruby user, developer, you can benefit from learning their experiences. An enormous volume of experiences already coded there to support zero downtime migrations. Also, actually, GitLab has many setups, many installations, and some of them may lag and need to. This is exactly the problem I described. I'm not sure if they keep some objects in separate files, probably not, but they have this problem. Deployments should be without issues on many setups, so it's interesting to check. I hope that one day they will open source it separately as a separate gem or like library. It would be great for Ruby developers.
That'd be really cool. There's a really good blog post, not really about this, but about zero downtime migrations from the team at Braintree. That's excellent. That I think I'll include as well. Since we're talking,
Don't forget to
about
include my log timeout post about this retries problem. It's a big
it. Will do. And yeah, I would love to hear from anybody listening to this that's screaming at us and saying that you've got this solved or you've got a really good process on your side. It would be great to hear how.
Yeah,
people are
maybe
doing
we are
this
wrong.
these days.
Like this episode is full of criticism, but it's opportunity to improve for our tooling. So maybe someone can say there is some very magic tool which solves all problems, right?
Yeah, let us know. Wonderful.
Okay.
Well, thanks, Nikolai. Thanks, everybody, for listening. Appreciate everybody that's got in touch recently with feedback. And yeah, looking forward to speaking to you next week.
Great. Thank you. Bye-bye.